This is Richard Ruth, and I'd like to propose a human-machine interaction change. That change would be to make forensic firearms identifications quantifiable using the National Integrated Ballistics Information Network, more formally known as NIBIN. The main concern of firearms identification is determining whether or not a bullet or cartridge case was fired from a particular gun. This is done by examining microscopic imperfections that arise during the manufacturing process of the firearm, as well as its continued use and abuse. These microscopic imperfections are imparted to ammunition components fired within guns. When the trigger of a gun is pulled, the firing pin strikes the primer and ignites the cartridge. The gunpowder creates immense pressure that pushes the bullet down and out of the barrel, and the same force acts in all directions. It pushes on the cartridge case and drives the slide rearward. This motion impresses the unique markings present on the firearm from manufacture onto the cartridge case, leaving the signature of the firearm on the cartridge case. Cartridge cases recovered at crime scenes can be collected and sent to crime laboratories for microscopic comparison. Firearms examiners visually compare the signature left on the cartridge cases to one another to determine if they were fired from the same gun. The main area of interest is the soft metal of the primer. If there is sufficient correspondence, an examiner can make an identification. This applied science is largely subjective in nature, as a human must visually compare items and render an opinion. There is no quantitative data to validate their opinion. Thus, some judges are finding the opinion of expert witnesses inadmissible in court. A tool is needed to aid the user, and NIBIN is a nationwide system that could provide this opportunity. NIBIN has one purpose, and that is to generate investigative leads. If a suspect fires a gun and flees a crime scene, the fired cartridge cases they leave behind can have their signature imaged and uploaded to the NIBIN database. The system automatically compares these images with one another in an attempt to link separate crime scenes and provide investigative leads to law enforcement. Suspects may be identified and arrested, potentially saving lives. Forensic and data scientists have been studying firearms identification and have proposed methods to quantify a human examiner's opinion. The change that I would like to see made to the NIBIN system would be to add a secondary function, and that is to implement a tool for the user to generate statistics on the likelihood of markings being made by the same firearm. This would require a small database of cartridge cases fired in guns that were manufactured one right after the other. Images of the primers on the cartridge cases would be stored and compared. The idea is to have a computer break down these images into cells and compare them to one another to generate a similarity score. The result of this computer comparison results in the type of graph shown below. Cartridge cases fired from different guns have a low similarity score. These results fall to the left of dotted line G above. This is known as an elimination. Cartridge cases fired from the same gun have a high similarity score and fall to the right of the dotted line H above. These are your identifications. For cartridge cases that might not look similar or different enough, they would fall between lines G and H. These are inconclusive results. An examiner would conduct their examination as they normally would with a comparison microscope. They would supplement their examination with this type of data to validate their opinion. They would upload their questioned cartridge cases in the system, and their images would be taken. The next step would be the new and secondary function to the NIBIN system. The user of the system could draw a box or highlight an area of interest that they believe constitutes an identification. The computer would compare these highlighted features to each other using the congruent matching cell method discussed earlier, and plot the results against the database of consecutively manufactured firearms. The resulting plot would arm the examiner with the data needed to validate their opinion in a court of law. Such a system like this does indeed have an open source patent by the National Institute of Standards and Technology, but it's never come to fruition. Ultra Electronics Forensic Technology Incorporated, the company that manufactures the hardware and software for the NIBIN system, would have to use this patent if they were to add this feature to the NIBIN software suite.